We are showing how ALGOR software predicts fluid flow interacting with the structure. We will use this 12-volt computer chip fan to show how ALGOR can optimize its design. Notice the rib that houses the wires is wider than the other two ribs. Those are thinner because they thought it might be a better design. Let's begin the experiment. The fan and the housing are rigid. The fan is rotating at 300 RPM. We are using smoke to dramatize the airflow. Notice the flow pattern near the narrow ribs. Now, let's go to the computer to see if ALGOR can make the design better. The finite element model of the blade and housing was made in ALGOR SuperDraw. The real fan was photographed with a digital camera to produce a bitmap. The engineer used a tracing function in SuperDraw to construct the blade geometry of the model. SuperDraw needs only a few mouse clicks to create the mesh around the blades. Next, a surface mesh of the remaining volume was automatically generated and fitted to the previously created mesh. ALGOR Hexagon made the 8-node brick mesh, connecting the blades and support. ALGOR's control software, Eagle, coordinated the changes in the geometry, the moving boundary conditions, the fluid flow analysis, and the animated visualizations to predict the airflow through the fan. Let's view the animation of the airflow over time. The flow pattern changes dramatically when a blade passes over one of the two narrow ribs. The first narrow rib stirs up turbulence, which is made worse by the second rib. The wide rib tends to smooth and straighten the airflow. Turbulence generated by the narrow ribs blocks airflow in 1/3 of the fan. So, using ALGOR software to optimize the design, the manufacturer could increase the flow rate, reduce the power requirements, or make a smaller fan.